Okay, so let's begin our lesson for today. We go for the next subtopic, which is ellipse. I hope you are not traumatized yet from your circle. I know circle is tough for some of you because the application is quite big, but don't worry, ellipse is a lot easier. Okay, although this is something new, but trust me, it's not that difficult. Alright, so let's go with traditional ellipse. Let's say that's your point of origin. So a normal ellipse will look something like this. Let's imagine it's a good ellipse then. Or an ellipse might look something like this. Okay, I know it looks kind of a potato and an egg, but hey man. Cut me some slack. Okay, let's call this is 0, 0 as well. Right, so this is what we call a horizontal ellipse. And this is what we call a vertical ellipse. Okay? And as you can see over here, that the longer one is here, for this one, the long one is here. And of course, I can say the short one is here. There's another word for that, for the long and short, which is what we call major and minor. Okay? So down here we call the major. And over here we call the minor. If I were to say more, I'll say this is your A, this is your B. Imagine this is an A, not a 9. This length. So as this length as well. Let's call this a B. So as this A, this is a B. It's like a radius for a circle, but we call it that. And the other characteristic that you need to know as well, the center is over here. Let's get to know them first, okay? So that's your center. This one is also the center. And oops, I think I draw a bad ellipse. I should have drawn a bit better, but then don't worry. The end of it is supposed to be the end. I'm sorry, this is not a good one. The very end is what we call vertex. This should be better. This is what we call vertex. Or you might want to call vertices. What's the difference between vertex and vertices? Vertex is singular, vertices is plural. So if I'm only referring to one, it's vertex. If I'm referring to both, it's vertices. Still a bad ellipse. And actually there's 4 vertex, if I were to be more precise. 4 vertices. This is also the next vertex. For matriculation syllabus, this is the one that they always mention. But if you talk about the whole thing, there will be 4 vertex. And sometimes we call this as the major vertex. Sometimes we call this as the minor vertex. Are you okay? because the major is on the long one, the minor is on the short one. But for matriculation syllabus, if they ask you for vertex, which one should you give? Only the major. Should you give all of them? You still got full marks. Alright? So I want you to have a look a little bit. The length over here is A. The length over here is B. Okay, let's study this one. And the origin is, the center is 0, 0. So this is how we write down the formula. X squared over A squared plus Y squared over B squared equals to 1. If you got yourself into a horizontal ellipse. As I've mentioned to you last time, the long one here over here, let's write it down such as this, long squared, and down here is short squared. It's easier for the brain for it to memorize. So what about if I give you for the vertical ellipse just now? What about for this 8 case? Then it's a switch of these two. Right? So if I give you the vertical ellipse, it will be x squared plus y squared equals to 1 divided by what? This one is the b squared. This one is the a squared. In other words, short squared, long squared. You okay? This is for the vertical ellipse. Those are the basics. One question. If I give you for the vertical ellipse, where is the vertex? Where is the vertices? Or to be more exact, where is the major vertex or major vertices? This will be the major vertexes. Where's the minor vertices? Over here. Are you okay? So that's the very short introduction. But I'm not yet done. There's something new that you need to learn. Okay. Okay, with the help of this compass belongs to who? Belongs to her, vertex. The compass, thank you very much. Okay, how do you draw a circle? You put this somewhere in the middle, and then you twist it around. And hopefully I can do it good. Yeah. Ha, not bad. And you got yourself a circle. Oh, you cannot see? Can you see now? A little bit? You got the idea. Okay, what do you call this point? The center. How do I draw the circle just now? I put these pointy parts at the center, right? And then that's how I draw from there. There's another word for it as well. Just for this case, for the circle case, the center is also what we call the focus point. Because You can say the length of everything. You reflect back. It got to the same place. You call the focus place. Or you can also say how you draw the circle is by putting your pointy part at the focus. Are you okay with that? We put this pointy part at the focus, and then that's how we draw. Right? For ellipse, however, is quite a different story. If I put this pointy part at the center, I can't draw ellipse. It's different. You need to understand that part. If I put this at the center, I could not get the ellipse. So how do we draw an ellipse? Well, yeah, you put a pen and you draw something like that. You either get a potato or an egg, like how I draw. Now, this is how we draw. It doesn't have one focus. It actually has two focus. Alright? This is what we call two focus, which is we call a foci for the plural. Singular and plural. Okay? And how we normally do is that we put two pointy parts at here, and then we tie it to a pen. We tie a string to a pen, and then we go around it. Then we have a Baymax. Okay, I'll show you an example. That is how we draw an ellipse, by using foci. Understand? Can you see there's a rope over there? There's a rope tied up to the marker pen. So there's the two pointy parts, as you can see there. I cannot see my mouse. There's two pointy parts here. One is over there, one is there, can you see? And they tie up to a marker pen. Okay, so that's how you draw a perfect ellipse. And there's one more interesting fact about it. As you can see over here, the length of the blue and the length of the red, if I plus and I square it, actually I got the same total length. I'll show you the formula soon. If the length of the blue plus the length of the red, it will always be equal. So you can also say that's the point where I focus things up. We will use the same concept for parabola as well. Okay, so enough about foci. You can check it out. You can search for ellipse animation GIF or foci, something like this. Yeah, you can see a lot of things. Okay, so let's get back. What information can you have from here? The center is and in the middle is what we call the center. If I say this is my major axis, this is what we call major axis. I missed one thing. The length of here is A, so the length of major axis is what we call 2A. Are you okay? The length of here is, this is what we call minor axis. If this is B, so the whole length is 2B. Very good. Where's the vertex or vertices? Here and here is what we call major. And here is what we call minor vertices. Are you okay? Now, where is foci? Foci is somewhere around here. It might be here, it might be here. This is your F, this is your F. Let's call them F. It stands for foci. Alright, class, I want you to understand a few things. Listen very carefully, pay attention for what I'm about to say. Foci is not the middle point. It's not the middle point. I've seen students, many of my students, they find this and the middle point and they call it foci. It's not the middle point. But center is the middle point for the two vertex and also the foci. Understand? Center is the middle point for foci and the two vertex. Okay? So how do you find foci, sir? Well, foci has its own formula. This is what we call this length. I think I'm a bit overcrowded there. Let's make a dedicated one. Let's call this a center. Let's call this a F. This length here is what we call C. And the formula for that is C squared equals to A squared minus B squared. Or what I would like to call it as, let's use the same color, long squared minus short squared. If you ask me personally, I like to memorize it in this way rather than A squared minus B squared. And class, give me attention one more time. Is C squared equals to A squared minus B squared or long squared minus short squared? Not C squared equals to A squared plus B squared. This is Pythagoras. I've seen students who calculate it this way instead. And it's obviously wrong. How do we get the A squared and minus B squared? Well, do you remember the formula? The A squared minus B squared, right? It's the same as this one here. A squared minus B squared. Okay? It's the same here. I know it's quite a lot of things. So, if I were to ask you again, what about for the vertical ellipse? Where is the foci? If this is the center, the foci will be on the major. Alright? It will always be on the major. If I were to be more exact, the major axis. What's the distance here, class? C. What's the distance here? How do we get C? C squared equals to A squared minus B squared, or long squared minus short squared. Are you okay? Okay, so far what we have learned is what we call ellipse on the origin. Now what about if? This time it's not on the origin. Let's say your ellipse starting over here. Let's call the center is over here. let's say the distance here is h, the distance here is k. This is k, this is h. So the new center will be hk. What do you think the formula will be? It's similar to the circle case. Where the circle, you got yourself x minus h squared plus y minus k squared. But for the center, there's r squared over there, right? But for this one here, it's still equals to 1. Okay? This is the difference between compared to the circle. And that's also divided by a squared over b squared. Are you okay? Now what about if we give you a vertical ellipse? I'm still going to say the center as the hk. So it's going to be the same, x minus h squared plus y minus k squared equals to 1 over a squared. Oh, sorry, that's wrong. Over b squared. The short one is over here. And this one is the a squared. Are you okay? So you understand the theory so far? Not as complicated as circle. You just need to memorize the formation of the formula. Okay, so now let's try some exercises.